The examples we just saw in just basic programming there were very simple examples, and in programming you can have some very complicated statements that produce and calculate different values. So these are generically called expressions. So expressions yield values. So where a value is expected in programming, i.e. something like a variable, there may be an expression which yields the value. Now that can be or take several forms. The simplest form is an assignment, where we simply assign a value to a variable. So x equals 10 or y equals 0.5, something like that. So we generally are giving a not a constant value, but a fixed value or a string literal to a variable and assigning it. We can also assign values from the variable, so we could say x equals y plus 2 or x equals y times 2, for example. A second method is we can pass values into other parts of a program called a function. We'll come on to functions later in the course. So we can pass these over as something called parameters. So parameters have a value, and therefore that value must have a data type. So we can pass parameters into functions, and those parameters therefore must be declared as variables that have a specific data type. We can use variables and values in conditional tests, so we can check to see whether or not a value is less than a certain amount or greater than a certain amount, or is maybe equal to a certain amount. So we can use variables in conditional tests. We can also use variables and values in the middle of larger expressions, equations and calculations. So we could say y equals x plus z times w, for example. So we can have a much more complicated expression, and we can have expressions that include function calls as well as fixed values. So we could say y equals 10 plus the square root of z, whatever z is. And square root would be a predefined mathematical function available in a programming library that would calculate the square root for us. So we can use expressions to build up very complicated statements and do the number crunching, if you like, that computer programming is so good at. So the value yielded by an expression must have a type. The data that the expression returns will have a type, and that could be numeric or it could be string. It can't be both, so it has to be one or the other. And if it is numeric, then again it could be one of the many subtypes. It could be integer values, it could be floating point. And if any of the values that are used within an expression are non-integer, then the result must be non-integer. Otherwise we're going to lose some potentially important information. If we multiply 10 by 0.15, for example, and store the value as an integer, then we're going to lose an awful lot of information. Many languages can actually guess at the data type that is produced by an expression, including Visual Basic, and we've talked about this with the option explicit value that can be turned on or off. And any language which is interpreted is capable of guessing at runtime what the type of data yielded by an expression is. This, however, does add processing and memory overheads to your code and should be avoided if at all possible. But many interpreted languages often force this type of coding. You can't declare your variables, as we've seen with just basic. You have to sort of force them to be a particular value, or let the computer decide itself what the value is going to be. And this can lead to multiple declarations, as explained earlier in this session, which are difficult to spot when debugging and can lead to problems in your program. So be very vigilant when using interpreted languages or compilers that can guess the data type without it being declared. It can cause you problems. So the expressions that we are dealing with in computer programming have operators, things like plus, subtract or multiply, and they have operands, the things that are being operated upon. And expressions can take a variety of forms, as we mentioned earlier. So A simple assignment, for example, it would be the variable x is assigned the value 10, so x is equal to 10. Another one which is similar, although it uses no fixed values like 10 is here. It uses other variables to assign the value to a third variable. So we're saying here that the variable y is equal to the result of x plus z. Whatever is in the variable x plus whatever is in z is assigned to the variable y. A more complicated expression would be y is equal to, and then we've got an open bracket, x plus z, close bracket, so that is done first, multiplied by w. So this is altering the precedence of the operation. If the brackets were missing, then the multiplication would take place first, so that z multiplied by w would be carried out first and then added to x, which would potentially yield extremely different values. So if you've got more complicated expressions, then you have to make sure that you understand the rules of precedence in computing, which are generally the same across programming languages. And if you want to be sure, then you can use brackets, and you can use generally several levels of nested brackets to force the precedence of operations. And the final example here is using a predefined function, which may or may not exist. You'd have to do a check on your particular programming language to see what the actual name of that function is. So we're assuming here that there's a function in this theoretical language called square root that given a value y will return us the square root of it, and we can then assign that value to z. So that is a mathematical function that would be available in a typical programming library. So those are some expressions. So what we'll do now is we'll return to just basic, and we'll do a few more slightly more complicated programs which can do some calculations with values and work with expressions in more complicated ways.